Okay, so I think we should get ready to start, even though Ryan's not here yet. Thanks for coming back for a second go round. Here's the agenda. And I think we're actually going to go top to bottom. Review last week just a little bit, see if there's any questions. I doubt there are since we're not very far in. Do a little in-class exercise, ungraded and informal, that relates to our design questions. And then wrap up the introductory lecture about context stuff to prime your pump. And that will hint at some of our design-related stuff, which we will turn our attention away from for the rest of the class as we dive into basic SQL querying. So querying is where we already have stuff in the database, and we're interested in getting a subset of that stuff out because our boss told us to, or because we need an answer to a question that by getting a slice of that data, we will be able to address. So that's the biggest part of using relational databases through SQL. That's probably the thing we spend the absolute most time on in the class, and it's the absolute most likely thing to lead you to being more employable at the end of this class than you were at the start. So I think it's good that we spend a lot of time on that. And we're doing a lab. We have a lab tonight. Should be easy, should be painless. The more lab you do, the less you have to listen to me blather on. I think that's good for both of us. And so that will be part of the deal. With labs, you're welcome to collaborate. You can copy off your neighbor if you'd like. There's no consequence to doing that. Work collaboratively. Ask me questions as long as you've made an attempt and can tell me what you've tried. I'll be happy to direct you appropriately, just short of giving you the answer. And in the off chance that you do not finish up tonight, and I'll try to plan so that everybody has ample time to finish up. If you don't, you have until midnight tomorrow night to turn it in. And likewise, if you have to miss class, it may take you longer to do because you won't have the resources available to you. So that is an option. Okay, so any questions before we get started? Yes, Bill.
Just to summarize our responsibilities for assignment wise. So just looking at Canvas, because I saw you posted everything. So just for my clarification, when we do a lab, the lab's going to be in person and it's technically due the next day. Wednesdays at midnight.
Yeah, I think your goal and my goal should be everybody except for the pokiest puppies gets it done before you leave. Because if you step away and it's not done, you can't ask me a question where I basically, hold you by the hand and lead you to the direction you need to go. So it's a missed opportunity. And it just, but yeah, if for whatever reason, if you have to leave early or if you missed and you still want to turn it in, any of those sorts of circumstances, and each lab is only worth 1% of your grade. So, you could miss a lot of points and still be in, a town. Although it's also the easiest points to get. So, but yes, your characterization was exactly correct.
And then the other assignments that are due before class, those are the independent ones. Just make sure they're turned in and they're based on a lecture from the week before, correct?
Well, they may be more cumulative than that. Okay. They should not involve anything that we haven't covered in class, of course, but you may need to draw further back than the last class.
And those will be done on, like, if we're going to use the desktop, we should come in here and use it instead of doing it on our personal device. Like those are all going to be coding related.
No, there will be most of them will be SQL, but some of them will be design. Okay. In which case you're going to draw on a piece of paper and take a picture of it with your phone, or you can use Visio or Lucidchart or whatever sort of diagramming you would like. Some of them can simply be typed into the text editor or word processor of your choice. Okay. Thank you. The one thing to take note of that people think is unsporting, and I've been called out for, so I'll talk about it at the outset, is you know, we walk before we run, and I hope it doesn't surprise or upset you that the labs are easier than the assignments that you do on your own time outside the classroom. You know, because it's generally, you get introduced to some hands-on topic here in class, you do a lightweight lab that's fairly straightforward. And with any luck, you're done before you leave, and that's your introduction to the topic. The assignments that you do outside of class on your own time are more demanding, they're trickier, that's no coincidence. And then, you know, my hope is that when we have tests, it's somewhere halfway in between. Not as easy as the labs, because the labs are designed to be easy, certainly not as hard as the homework. The homework is supposed to, you mull over and you have challenges and so forth. The other thing to say about the assignments on your own time is you don't have to do perfectly on them to get a strong A. There are some of them that, you know, the SQL ones you should be able to do. But the design ones are going to be like, I'm not at all confident that I got this right, and that's okay. And there will be things that you got wrong, and you can still get a really strong A on them. Because design is like designing a house. It's not going to be perfect. What's a perfect house? What the hell does that mean? You can either have a really good design or a really bad design. It's usually pretty easy to tell what a good design is, what a bad design is, but it's not going to be perfect, and that's okay. Other questions about assignments? Because that was a good one, and it gave me an opportunity to warn you about the disparity between the labs and the homeworks. Anything else? No, okay. Review from last week. We talked about it. I don't want to bore you too much with it, nor do I want to necessarily put you on the spot. A database is just a collection, an organized collection of data. Data is symbolically represented facts about the world. Information lives in human heads, and it, uses data in the right time, in the right place, in the right format, with the right visualizations and so forth, to live in a human head in a way that allows to inform decisions. A database management system is a piece of software, tends to be pretty large, some commercially available, some free and open source, that manages a database or multiple databases, ultimately, provides centralized access to the data stored therein, and also does things like security and access control and backup, and manages concurrent access, and all the other sorts of things that systems that need to be used by an entire enterprise need to have made available to them. So that's kind of the hierarchy of stuff. Let's jump in to the exercise. So this may seem like a weird thing to do, but I am hopeful it will help make visceral and memorable the reasons why we worry about design, why design is as complicated as it is, and why we have models to represent data, and why redundancy, uncontrolled redundancy, is our arch nemesis in database design, be it relational, as it is in this class, or some other mode that we'll talk about in passing throughout the course. So here's the scenario. You work for Spotify back in the days that it was a startup and just getting ready to launch, and you work in some sort of data capacity. What I would like you to think about and brainstorm are the individual items of information, the attributes, the columns, if you will, in an Excel spreadsheet that we would need to store if we were planning to launch Spotify or iHeartRadio or whatever sort of digital music streaming service you favor. Apple Music, I guess, is still a thing. What are the pieces of information that you're going to need to store? And I would like someone to actually take keyboards to text editor or pen to paper to brainstorm a list. Obviously, you're not going to get everything, but give some thought to the pieces of information that you would have to capture to provide a service like Spotify. And you don't need to worry about behind the scenes stuff, just focus exclusively on the user experience and content. And imagine, okay, what you really need to do is provide the stuff that's going to make a user want to go to their computer or handheld device and use the service for the purposes that the service was intended. Do I need to say, and so there's no technical skill here, it's just brainstorming what you would have to capture, okay? You're more than welcome to talk to your neighbors and so forth, don't be shy, that's going to be important, this, it doesn't matter, but it's gonna be really important for the labs. And I want you to just spend, 5 minutes or even less maybe, sketching out the pieces of information that we need to capture. Is that actionable? Yes, Tristan says yes, and he's answering for all of you. So if you have questions, I'd certainly be happy to answer them, otherwise go nuts. Just a brainstorm list, it'll be much longer than you initially imagined. Sure. I'd like you to develop a list of the attributes, the pieces of information we would need to have to keep track of and make available to author a application like Spotify. Things related, I hear other people talking about artist name and track name, like, so that sort of stuff. Just like, and think of as many as you can. Yeah. And again, this is not technical, but we'll take it from there and hopefully it'll grow into a lesson. Nice watch.
There's one, it's like if you're trying to find something. Like Frank Sinatra, I won't give you that.
Synopsis like shoot. List of some words I relate to flowers.
Barbara Streisand. It's not gonna help.
When I look up name, Jay-Z.
Oh, Jay-Z, it is Jay-Z.
It's his album.
Like published.
Yeah, here.
Album.
I had a part, so it was my listener.
Same thing.
All right, 1 minute warning. No, I'm having a bad hair day, aren't I?
Good. Great. Tweak things. kind of odd. I don't know.
There are no bad ideas in brainstorming. Remember, there are no stupid questions, only stupid people. No.
So is it like, it's, well, like I said, like, if you go back there, call it.
Exactly.
Like from the back end.
The data that they would need to provide to make a system that someone would want to use for its intended purpose.
Okay.
It's gonna, you know, I heard people say artists, you know, it's gonna have to be information about artists. What information specifically? And the more you think, the more there appears. We don't, well, just give it thought, your personal contributions will just be offered up for the good of the group. And let's do that now. Wherever you stand with this, let's start developing a list. And the intention here is to demonstrate why we need to deal with redundancy and why we need the relational part of a relational database or some alternative approach to cope with redundant data. So imagine all we had was a two-dimensional table, a single two-dimensional table is what we'll get to. But to kick that off, what's the first thing? Somebody volunteer a attribute or an individual item of information that we would need to keep track of and present to the user to be able to offer a functioning music streaming service. Yes, Sean?
Artist,
Okay, so artists, what specifically about artists?
the name. So
Artist name.
yes.
Okay, artist name. So I'm gonna warn you, I found that writing on the tablet works better when we're in a room where it works, which this one seems to be. My handwriting is disgraceful either way, and it's barely legible and it's ugly and unpleasant to look at. There's nothing I could do at this point in my life about that. But okay, artist name is a very great place to start off. What else? What else we came up with? Madison? Producer name presumably, yes? Okay, so producer name. What else we got? Just call them out. Josh.
Song name?
Song name, yes, song name. What else? Lyrics. Genre, yes, good. Like it. Duration, yeah, absolutely. What else we got?
Album?
Album, certainly. What about album? Well, album name, let's say. Album name, to be more explicit.
The user's name.
Let's keep user aside, just focusing on content. You're absolutely right, but let's call that kind of a behind the scenes thing. Just to constrain, Eric.
The album covers.
Cover, yeah, so cover image. Cover image, I'm gonna call that. And that would be that could be a actual stream of ones and zeros. You can store images, you can store video, you can store software and applications, you can store those things in a database directly. You can also instead store a pointer to a more traditional file system, so a name or a link, so that you can store those things on a disk more traditionally, and then just point to them in the same way that you would if you're developing a web page or something like that. There's pros and cons to each, but it's useful for you to be aware that we can store digital information as well as extremely large things in a database if we so wish. The juice isn't always worth the squeeze, but yeah, that's all good stuff. Well, somebody else had something. Sean, was it you?
Just say like we were saying file type, it could be.
The file type, sometimes that's exposed to the user, sometimes it's not. What else we got?
Like how many times?
Yes, listening count, I like it, listening count. Listening count. What else?
History? Like what you've listened to in the past?
Let's stick that as absolutely a necessity to run the system too far afield from the content area that we want to focus on. We're going to put that with user and anything related to use. We're gonna hold that to the side just because it gets more complicated. Bella?
What about like artist description? Could they give their backstory?
Yep, artist bio. Artist bio, I like it. What else we got?
The shuffle and skip count, it's like the user.
We'll call that user and. I'm sure they're amazingly sophisticated with those things. I'm sure they're storing it on the server as well. You know, if a song is skipped over partway through, just like, you know, think about online shopping. When you build a shopping cart, but then never press purchase. And I don't know if this is just my perversity or if it's an old person thing, but I love nothing more than to sit and imagine I'm going to purchase some really great stuff and put it in the cart in Amazon and then just abandon it because there was no way I was ever going to buy it in the first place, but it was kind of fun to imagine I would. Well, you know, they don't delete that information from their system. They take full advantage of the fact that there's something to be known about. Maybe the array of stuff that you put together is really kind of weird and idiosyncratic, but maybe there are patterns there. Maybe there's insights to be extracted. Maybe there are price points to be understood, you know, below which you might actually pull the trigger. And there's all sorts of stuff to be learned. So that just because that those data don't actually go into production as an order doesn't mean they go anywhere, of course. So yeah, that's an important insight, and I'm sure that's in there too. What else we got? Anything else? It's a great list. Tristan?
Release date. Like the day it was released.
Oh, release date. Yes, absolutely. Absolutely. Release date. Okay. Yes, Mark.
Subscription cost.
So the financial stuff, absolutely essential. You got to make money with this thing, but we're going to stick them aside as too far afield when it comes to content, necessarily. But yeah, no argument here.
And customizations,
Say more about that.
like, I guess like that's like user base, or even like in terms of like transparency, like this, like in songs, right? So you can like go in settings, like Spotify settings where, okay, you can like fade out some segments of like the beginning of a song and fade to the next one, like stuff like that.
Yeah, so that's getting sufficiently sophisticated and technical that I wanna hold it to the side, you're absolutely right. And those are things that I think, and it's interesting. Some of that is going to be requirements of the actual software that some software developers are going to have to program into the system, right? So it has to be, you know, somebody has to make the actual application. And there could be these edge cases where some of that data is going to live in the software that someone downloads and installs, and sometimes that's going to live across the internet, centralized in the back end of the system in a database. So, and of course, I don't have any, I've never worked for Spotify or anybody, I don't know how all this works. But yeah, whether you want the music faded in or out, I think one way you can tell is whether those settings follow you from one place to another. If they do, they probably live on the back end, and if they don't, they're probably on the client software itself. But these are, so this is a very fast and easy and informal introduction to some of the stuff that you need to do when you're designing a database. Here, we're just kind of spitballing, but if we were doing this for real, typically you're not doing it for yourself, you're doing it for a client, either your employer or if you're a consultant for someone else. But you have to find out what the system needs to capture to design the database. If we were IT majors, we would spend a lot of time on that, but very few are. I think there's a couple CIS, but very few are. So we're not going to worry about that. There's not a lot of technical stuff to it, but it is an art. It is critically important, and we're going to kind of blow it off more than we should just to get to the stuff that pertains most to business-oriented pursuits. Addison? The writer's name or composer's name, do we have anything like that? Yeah, I'm gonna call it composer. I think that's pretty much the same thing. Track number, If you were dying to throw down with track number, I apologize, I stole it from you.
Artists, monthly listeners. So you get like a popular artist pop up, not like a brand.
Yes, so I'm so glad you mentioned that, Anthony. You're absolutely right. But this is one of the subtle things that we have to start thinking about and developing a sensitivity to. And there's no world, I mean, you're not wrong or misguided. It's just there are things that have to be stored in the system for us to keep track of them. And then there are things that we need to know about what we have stored, right? So what we'll need to store is every instance of a user playing a particular track, whether they bailed on it, whether they skipped over it. But the stuff that is necessary for us to answer that question has to be stored in the database. That question itself is going to be a query. You know, how many times was this artist played over this period of time, right? That was what you were suggesting, wasn't it? Yeah, we have to know that for a variety of reasons. We want to know who's popular and who isn't. Our users are going to demand who's most popular and who isn't. And we need to compensate the artists, not much, but we need to compensate them in accordance with their popularity. But that's something that we're going to ask of the system that we design, rather than needing to be something that has to find its way into the system somehow. So what I often ask people to imagine is, can you imagine someone somewhere typing it into the system? And if the answer is yes, it's probably an attribute that we need to design into the system. If the answer is probably not, it may be a question that the system needs to answer rather than an attribute that needs to be stored. If that distinction is opaque at this point, it's completely fine. But since you said something that brings it up, I want to kick it out there because it is a persistent source of confusion throughout the course as we get into it deeper in the weeks that will follow. Sean?
So wouldn't listening count fall under that, like if it's one of the attributes that's kind of shifting?
Yes, did I put that down?
Yeah.
Yeah, I did. Okay, well, shame on me, I fall into the trap as well, you are absolutely right, Sean.
I was gonna ask there.
That is, yeah.
Databases for like shifting variables
Yes.
that, no, now.
Yeah, you are absolutely right, so listening count is something that will be tabulated. It's easier to tabulate, it's less complex a query than yours, Anthony. But it is something that we will learn from the system rather than something that we have to type into the system. What we need a record of in the database is every time any user listens to anything. That every time that happens, we need to keep a persistent record of that. And from that, we will tabulate listening counts. We will tabulate the number of listeners who listen to a particular artist in a particular time period. You even get where your artist is most popular. Routinely, the people I listen to are most popular in Los Angeles, I don't know why, and in the Scandinavian countries. Nothing about my music is Scandinavian, but I think it's interesting to look at that information, and obviously they have the capacity to do that sort of query, to provide you that information without your even ever asking for it, which is kind of interesting. Any other thoughts or, yes, Tristan?
The audio, like the actual song itself.
The song, I think we got, I know you can't really, so we got song name, oh, right, so the actual encoded stream of information. So something about the files, we have file type, actual file. Okay. So I'm going to draw a line under some of these: artist name, song name, genre, duration, album name, release date, track number. Just because we kind of have to pick a subset. Somebody throw out an artist.
Zach Bryan.
Zach, I don't know if there's a C in Zach's name, there probably isn't, sorry,
You're
is
fine.
is that a country sort?
He's like country alternative.
Okay, I hear that's what that's what courses out of the speakers in a lot of, my son goes to Temple and he's like, yeah, you hear plenty of hip hop, but really as much as anything, you hear pop country on college campuses. That is a new development, ladies and gentlemen, especially at a place as urban as Temple. You could knock me over with a feather to hear that, but I guess further to that. Yes, sir.
It's actually Brian.
It's Brian.
He,
I'm sorry.
it doesn't
I
matter.
mean,
but
no,
I didn't want you to like walk around and say, I heard about Zach Ryan, you know what I mean?
No, the only country I like is like Hank Williams, not Junior, like Hank Williams. Real honky tonk, honest to goodness, drink yourself to death and die penniless from gambling, old school country. And even then, only when I'm in the mood, generally when I'm into the whiskey. Don't quote me on that. Okay, so Zach Bryan with a B apparently, hopefully a Y. What's his song name?
Revival.
Was that Survival, Revival?
Revival.
Revival, see now you're making me look real bad here. Revival. Revival, the genre, we'll say alt country,
Sure.
and the duration, whatever, 3 minutes and 20 seconds. What album, do we have any idea? XYZ album, who knows?
Revival single.
Well, let's make it a real album though, just to prove my point to some extent. Release date, whatever, 1/1/2024, doesn't make any difference. All right, so do we happen to know another Zach with a B Bryan song?
Spotless.
Zach Bryan, Spotless, all country. 4 minutes and 1 second, XYZ question mark, and 1/1/2024, assuming it's from the same album. And imagine that we were doing the entirety of XYZ question mark album. It'd be nice if we had a real album handy, but we have to keep writing Zach Bryan every time. So a new song, still alt country. This is different, let's say 2 minutes and 57 seconds. This is the same. And this is the same. And what we'll find is we have to duplicate a lot of this information over and over and over and over for every single solitary song on the album. So we'll get a whole ton, say there's 15 songs, not unheard of, on the album. We're gonna have to duplicate Zach Bryan 15 times. These will all be different 15 times, that's fine. All country will be duplicated 15 times. These will all be different and bear meaningful information that's specific. This will just be duplicated over and over. This will just be duplicated over and over if the entire album's worth of songs has been released at the same time. Never mind things like artist bio. Artist bio and pictures, we probably have a half dozen pictures for a given artist. We have that biographical information, sometimes it's short, sometimes it's long. That redundancy causes serious problems. And the most obvious problem is the space it takes up to store these things, right? That's inconvenient. Never mind that, this is just one album's worth of stuff, and we already can see all this information being needlessly duplicated again and again. The other thing is, if we update some information that is duplicated, we need to change it everywhere it appears. We can't just change it once. So it's this fact that motivates our sophisticated approach to designing a database. It motivates the relation part of relational databases or competing solutions to this problem. It's not just about redundant space that could be better used elsewhere. Storage is cheap and getting cheaper all the time. That's not the thing. The thing is, as soon as you fail to store one fact in one and only one place, stuff starts to go terribly wrong. Okay. You get one fact showing a value in one place, and that same fact showing a different value in another place. That is bad. It's extremely difficult to know which place is the most current, accurate, and up-to-date place. There are no end of challenges to this sort of situation. So we do something about it. How's it going, Ryan? So what we do in terms of relational databases is we take chunks of this information that hangs together and we put it together in one table. And we take other chunks that themselves hang together and put that in another table, maybe a third group that hangs together and put it in a third table. And then we relate those tables together to one another. Okay. So do we have any sense of how subsets of these data that we came up with might hang together? Does anyone have an intuition about stuff that would go together and stand apart from the rest of the stuff? Where are the natural breaking points, Bella?
Qualitative and quantitative.
So that would be an interesting approach. That is not the approach that we pursue here. Take a look at what. So I did little dotted lines when things are changing with each row here, and arrows where they tend to be staying the same. So take a look at what are the things that are going to be meaningful and different with each row in this giant table. Zach Ryan's just, oh, okay, Anthony?
Title of the song.
So we got title of the song, changing each time. What else, Sean?
Duration.
Duration, changing each time. What else, Madison?
Well, I guess
It could. This is another thing that is super important. Where are we tracking these things? What's the granularity of this data? So it's an important question to be asking yourself. Maybe especially, services like Spotify have led to a proliferation of a lot of singles, right? So singles have release dates that are going to be different by song. An album might be released all at the same time. It might not be. On Spotify, you got the song that the A&R people say is going to be the hit. That gets released before the rest of the album. The album comes out in dribs and drabs to try to torture the real fans into actually purchasing it before they can listen to it in Spotify, right? So that's an important question to ask from a design perspective: is how is this stuff going to vary? Is it going to vary song by song? Is it going to vary album by album? So it's good that you ask that.
I said main track number.
Yes, track number is definitely something that's going to change every single solitary row in this giant two-dimensional table. So let's review the things that are changing. Song name, duration, track number, for sure. Lyrics, we didn't put it there, but lyrics. So what do all of those attributes relate to? Song name, track number. Call it out if you got it.
The song itself.
The song itself. So it looks like the things that are changing every row relate to the song. So song is an entity, is what we're going to call it, about which we need to capture pieces of information. So we have this song entity or category that hangs together. What other category of things might hang together? Josh? Artist, yeah, absolutely. Artist is going to hang together. What else?
So like the album.
Album.
Like start sorting the albums out.
Yeah.
Like on the same release date
Yep.
and.
So absolutely, we've got a group of artist related things. We have a group of album related things. We have a group of song related things, and we can identify them and tease them out. And as Madison said, some of them are going to be like, we need to understand how we want these to vary, like genre. Do we need to do genre song by song? Probably, but maybe not. Maybe we want to categorize an artist as belonging to a genre. Maybe we want to categorize an album by genre. Maybe we care a lot about artists who switch up genres further to alt pop country. Garth Brooks became some emo guy briefly, as I recall. I don't know how that worked out for him, but he did. But would that count as the same artist with two different genres? Who knows? Because he also changed his name. Would that require a separate artist category, a separate entry in an artist table? That's an interesting question. So these are design related matters. There's a lot of them, but the biggest one and the hardest one is going to be identifying these entities, these categories of things that we need to capture information about, and how they relate to one another. We will come up with, this is just willy-nilly and ad hoc and crazy and certain to be riddled with errors. We are going to learn a painfully systematic step-by-step way of coming up with the entities, each of which will become their own table, and the relationships between and among those entities, so that we can algorithmically approach this problem instead of just kind of spitballing and brute force common sensing it out. We want to eliminate any opportunity to have to use common sense, because common sense is not nearly as common as its name would indicate, and we are really looking for techniques of stupidity minimization, which of course is harder than it sounds. So there's, a very informal, fast, and your mileage may vary. I think a useful and eye-opening mechanism for revealing how there's a problem that needs solving, and it can be solved by multiple tables related together. Now I want to treat this a little bit more formally and go through some slides to make sure that I have this in a way that's going to serve you well. Okay. So a data model is what will allow us to do this stuff in a more disciplined way. It's an abstraction. We're stripping away stuff that doesn't matter and keeping the stuff that does matter. And these, of course, are available to you. You don't need to write any of this down, although obviously you're more than welcome to. One of the biggest changes over my however many years of teaching, what is it? I don't even want to know how long it's been since 2000, though. I know it's been a quarter of a century. Time flies, I'll tell you. Don't get old, people. It sucks. Is students in 2000 used to take a lot more notes. Now you have the computer and everything. Hopefully it's less, you pay more attention and take fewer notes. That's all well and good. In any case, data model is an abstraction of how we represent the stuff that we need to capture information about. It's how we think about model relationships, and it is the solution to the problem of trying to figure out, okay, yeah, there's artists and there's albums, there's songs. That's a really easy, straightforward, and familiar example. What if you're designing something, a database about protein folding and genes and sciencey stuff that you don't know anything about, and that's incredibly complicated? Okay. So there's a bunch of different kinds of data models, and there's a bunch of levels data models. I don't want to harp too much on the ones we aren't going to worry about, but let's real quick review the ones we are. Our model will be a table. Columns will be attributes. Rows will be records or tuples or tuples or rows. The column is a consistent thing that we need to capture about the things we want to capture information about. A row is an instance of one of those things. Okay. There's other modern ones. Yeah, my apologies for this. If you have to crane your neck, I don't think there's too much I can do about that. You may be familiar with hierarchical databases, Active Directory. If you're an IT sort, if that means nothing to you, that's fine. But Active Directory is a mechanism to manage an organization's information, particularly as it pertains to logging into systems in that organization. It's hierarchical. At the top level, you have an organization-wide domain. You can break that into subdomains. You can break that into departments. You break the departments eventually into individual people. Each individual parent level, like that, each level here, this level can have multiple things underneath it, but each individual instance rolls up to one and only one parent level. That's an approach that has worked very well. But let's just focus on ours. We don't need to focus on the other ones really. And oh man, I feel like I'm repeating myself. So let's just make sure this has been gone through. Tables we talked about related. The relationship in relational database models is linking tables to one another. Everything needs to have a name, and that is something we talked about last week. Metadata, the fact that tables and attributes and schema and all that stuff, we have to be able to refer to it to get information out of the system. So we need metadata desperately. Just because you know what you want, you need to know how to refer to it as well. It can be a pain in the neck, frankly. So where a column, which has one kind of information, and a row, which has a specific instance of the stuff we're capturing about, where they intersect, you have a cell in the spreadsheet. And there's an interesting constraint that is important. And then I'm going to jump around a little bit. Let me find it. Yeah, here we go. Where those two intersect in our model, and this is important and a little bit conceptual, that cell can only have one atomic value in it. You cannot put a comma or set operators in a cell in databases. One single atomic value per intersection of row and column. This is called first normal form. Lucky for you, even though it's foundational to introductory database courses all over the country and world, I've taken normalization out of this course because it's really confusing and doesn't really get you a lot of useful stuff. So I took it out. But the one thing we do need to be aware of is this constraint. Whether you remember it's called first normal form or not is not important. But for our purposes, one thing, one song can have at most one genre per cell. Yes.
So does that go into? I'm gonna go back to artist name. So like Zach Bryan, since it's 2 words,
Oh, no.
that's different. So
That's
alt,
different.
but like alt country, let's go back, like use that as an example. Is that still considered one genre?
Well,
Or is that, or that's up to us to decide?
that is a design decision, absolutely, and it's an interesting question. It depends how we would be interested in building genre. Do we want to say, okay, we've got foundational base level genres, one of which is alternative and one of which is country, and one of which is hip and one of which is hop, and we're building that, but probably not. But you could, and there'd be other instances where that's exactly what you want to do. That's a design decision, for sure. And probably, if I had to guess, at Spotify, it would be alt-country. That string of text is one of the genres that they have decided to make available. And they do it in response to what artists are doing and how consumers are conceptualizing information. But one thing to be very clear about, just because a value is 17 pages long doesn't mean it's multiple values. What we're talking about is, imagine a data analyst or a computer programmer in a database of data analysts, and we're keeping track of maybe we're a placement agency or a consultancy where we need to find people who can do a particular job that we've been retained to contract. And so we have an expertise database. And we've got our contractors and then the skills that they have. Well, much like we learned when we did the introductions last week, you know, nobody here has one thing. You got a lot of things. You can do Tableau and Power BI. You can do SAP and some other ERP system, and you can write JavaScript and Python code, and you know SQL. So it is absolutely necessary that we accommodate attributes that we want to store, about which our instances or rows or records or tuples will have multiple things. So we got to figure out how to crack that nut. We just can't store it in a single cell separated by commas or with braces to indicate this is the set of stuff. That is not our solution. That is not admissible. That is not above board for our purposes. There are modern alternatives to our relational database solution to this problem that do allow that. One of the other data modeling approaches in a class of data storage solutions called NoSQL, meaning not only SQL. One of the most popular types of NoSQL database is a document database. Document databases have MongoDB, sometimes pronounced MongoDB, is a really popular one there. You may have heard it, doesn't matter if you didn't. Document databases absolutely have no problem with a single value being a set of 50 different things. You can put 50 different values in the equivalent of a single cell. That is completely fine with that model. That has advantages, that has disadvantages. Those alternatives are out there. Some of them are proving to be useful and interesting. None of them is as widespread or universal as relational databases and SQL. It's important to be aware that this is a constraint that's kind of self-imposed. It is an essential feature of the model that we're going to learn throughout this course. The other thing is that, you know, if we're breaking related information apart and storing it multiple separate places, which we are, you're going to have to worry about getting that information back together again. So we're going to have to keep track of the relationships. How do we do that? Two ways. One, and this is an even more foundational condition that we abide by, is every table that we interact with or that we design or implement needs to have a unique identifier. We'll call that identifier a primary key. That's not important for right now, but we have to make sure that we have a mechanism for uniquely identifying every instance of the thing that we're storing in a single table from every other instance. If we can't do that, our system falls completely and hopelessly apart. Okay, so we can do that with, the most common way to do it is just come up with a completely synthetic identifier. And they're so common in the 21st century, you don't think much about them or what they are. But, you know, you have a student ID, you have all sorts of different IDs that are assigned to you all the time that you need to keep track of, or perhaps not because it's on your identifying card or whatnot. So that's the easy way. You know, your student number, if it were a different number, your life would be absolutely no different, right? It wouldn't change anything. But we need to know yours because it identifies you as opposed to some other Ryan, Ben, or Anthony. So we just assign a synthetic number. Sometimes we, instead of doing that, take one or more actual information bearing attributes and combine them together and say, we're confident that this combination of attributes that we want to keep track of anyway, we're not making anything up, will uniquely identify every instance of the things we're going to be storing in this table from every element. That's dangerous, that can bite you on the butt. Sometimes we can do it and do it confidently, but we have to have that unique identification. Why? Because we're going to use that identifying column or columns that we decide on that we'll call a primary key to connect the information that we very intentionally broken out across multiple tables. So imagine in our example, we're going to have an album table. We're going to have an artist table. Obviously, our listeners are going to want to browse albums and songs according to their album and albums according to their artist. To do that, given that we split that across into independent places, we're going to have to be able to relate them back together. So that primary key in one table will be inserted into another table as a visiting key that just provides the connection between the two tables, so we can reunite or join that information back together again to answer the sorts of questions that the operation of our system is going to necessitate from Jump Street. Like, what's the latest album from Zach? Brian, not Ryan. So that's an essential piece of designing a database, but it's also an essential piece of using a database and understanding how to do it in a sophisticated and reliable way. So we do the design so that you get really good at understanding the whys and wherefores of the actual use and the querying through SQL, because that's the skill that's really likely to stay with you most. Okay, so I think that's enough of that. Let me just double check that I'm not skipping over anything critically important. Bear with me one moment. There's a lot of synonyms here. We'll try to keep it real simple. A lot of terminology in a database class is very weird and very sounds like we're trying to impress one another with how arcane and sophisticated this stuff is. And sometimes that's true, but the whole deal, the whole breakthrough came very explicitly from mathematics, and particularly the mathematics of set theory. We don't need to worry about that. We're not going to dive into it. Other classes, more technical, more computer science, you might. But when we talk about concatenation and cardinality and participation and tuples, we do so because of this connection to set theory, about which I know next to nothing, by way of confession. But column, field, attribute, row, record, tuple, a lot of synonyms. I'll try to be consistent and I'll routinely fail. We already talked about that. Metadata, I think I already hammered on this. We need to be able to refer to stuff. To refer to stuff, it has to have a name. That name is incredibly important. That is what will, the names of things is what will make up our queries. We have to specify, okay, this is the table we're interested in seeing. These are the attributes within that table that we're interested in seeing. These are the attributes that we're interested in filtering in accordance with, so we only get the records we want and not the 115 million ones that we're not interested in. Metadata makes the world go round for us. The metadata itself is stored in a table that's exactly the same sort of table as the data we're interested in the first place. So if you have administrative access to a database, which you don't in our database, but if you did, you could go in and see that all of the metadata about tables and attributes are themselves stored in tables that themselves have names. That's really metadata. So it's the data about the data that stores the metadata. That's pretty wild. Everything is self-describing. But that's not super practical. We're not going to worry about that too much. There are alternatives to relational database, we already talked about, and not only or no SQL, that's probably the most important and growing one. Let's talk about their data models, we already talked about document. Key value is just, hey, here's an identifier, this enables us to identify something, and this is a single fact about it, and that's all we have in our entire database. And yeah, that's enough of that. I get too fired up and then we burn too much time, we don't get into actual practical stuff. So here's a distinction that will be useful because it's confused people in the past. The difference between data model, which is what we talked about this evening thus far, you know, relational versus alternatives and how we're thinking about data at high level and low level. Then there's data modeling, which is an approach to design where we have a specific problem, like, hey, we need to design Spotify. That's a technique that we'll take to come up with a specific design for a specific database that does a specific thing, that we can break from a high level pictorial representation to a specific game plan for the tables, the attributes in each table, and how we will relate those tables together to address a specific problem. That is data modeling. That is the design stuff that we'll do in the class, although not tonight. How are we doing on time? Not super great, but that's okay. Yeah, that's fine. Okay, there. I think that's everything we need to talk about there to primer pump. It's a little early for a break, so let's not. I would call upon you to fire up your MySQL if you would like to follow along. Let's shift gears. We did this, we did this, we did this. Let's talk about SQL. A note on, please go away. Very good, thank you. A note on our Canvas setup here. Why are we moving so slowly? You'll notice under week 2, we have this SQL tutorial, which is what and I know that's not terribly big. Let me see if I can't make it a little bigger. There we go. Many weeks we'll have a SQL tutorial. This is your no nonsense, nothing but the stuff that you need primer on SQL. It is not particularly elaborate. It in conjunction with the lecture, I'm hopeful it will get you where you need to go. You can also turn to online resources. W3 Schools is a really good, straightforward resource that I strongly recommend as you are introducing yourself to SQL. It is often disparaged as limited and baby steps oriented, but that's why I think it's exactly where everybody, including me, when I'm learning something new, should start, because it's the easiest place to get your pump primed. Don't stop there, but start there, for goodness sakes. In any case, what I will mention to you is you will need to refer to these documents. They are extremely useful when you're doing your assignments. You know, they have examples that are very similar to what you'll be called upon to do in the assignments. Not exactly the same, but similar. So you need to go through them and look at them. Please, for goodness sakes, you'll be burning a lot more brain fuel if you don't. These will step you through much of what you need to be able to do. The other thing I would encourage you to note is that these examples, you can do these. You have access to every SQL statement that is in all the tutorials. So, and sometimes we'll step through it in class, but you can also do it on your own time, and these will all give you actual results. So let's talk some SQL. So further to metadata. First thing we're going to learn how to do is access metadata in the database. It's not as important given that you have this, bless you, nifty graphical client. It's not as mission critical, because if you log in to your MySQL and you go from the administration tab here to the schemas tab, And you find the employees database here, and you click on tables and click the down arrow. Here we have all of the table names in our employees database. So metadata is much more riddle. I wish I could make that bigger for you. I have no way to do that. I can make the actual SQL as big as I want, but I can't make this any bigger. Hopefully you have it in front of you. The metadata is much easier to get at than it used to be when we just had a black cursor or a white or green cursor staring at us in a black background. You can see that there, the employees table has a the employees database has a department table. That department table has department number and department name as attributes in it. But I do want to go through, because there may be occasions where you need to, some of the SQL to see the metadata. The first thing we want to do is show what databases are available. Keep in mind, databases is a stupid name, given that the whole thing is a database. We could think of a database as synonymous with a schema, which is also an obscure and opaque name. Basically, what either of those two terms means is just a directory or a folder where related data is stored together and separate from everything else. All right. So to see a listing of databases, we can simply show databases and we see output basically exactly what's already over here anyway. One thing you do need to take to pay attention to is when you double click on one of the databases over here in the left hand column, double click on it, you see how it becomes bold? That means that's our default database. And if we have a default database, then we can refer to a table without prepending its database in front of it. So if I right now want to select something from the employees database, select asterisk is just a stand-in for all the attributes in the given table without having to specify it. So if I want to select all the attributes from the department table here, you see this guy, department. I can't just say from department. And this could potentially screw you up quite a bit. If I do that, it will say table fabric.department does not exist. Why is that? Because our current default database, the one that's bolded, is fabric. And the department table is not contained in the fabric database, it's contained in the employees database. So if you're not dealing with the current default database, you need to put the name of the database in front of the table as such. Employees dot, oops, probably should spell that right. Employees dot department. You can always use this syntax no matter what is your current default database, and it will give you a result. And here's our output right here that I can also not figure out how to make big, alas. In any case, if you use the fact that you have the opportunity to specify a default database, you don't need to worry about prepending the database name when you're selecting something from a table. So select all from clients, I can do without having to put fabric.clients because fabric is my default database. You can also achieve that by using the use command. So if I say use employees, you see how it just made employees bold? This statement is tantamount to specifying a default database. Nothing earth-shattering here, obviously. Couple of things to note. You will often see or hear that a semicolon is necessary to terminate every SQL command. If you're dealing interactively with a client, it is, which was an old school way of having to do. Or if you're writing SQL in the context of software development, if you're writing code that involves SQL, you will need to use this semicolon. The idea is you've got a server sitting and listening, and it needs to know that you're done and you want it to do its magic. It needs to be told that if you're dealing interactively, the way you send that, okay, I am done giving you stuff, I want you to interpret it and act on it, is with a semicolon. With a more sophisticated client like this, you can just press a button to tell it you're done. Or use a shortcut command. So to execute a SQL statement, you can use this lightning bolt here. Will do your entire script. The lightning bolt with a little cursor will execute under the cursor, so it will do one line only. Or my personal favorite, because I'm a keyboard shortcut addict, is if you type some stuff and press Control and Enter, it will execute what you've typed. Okay. So if we were, so I guess what I want to say is that part one of your tutorial is sort of old-fashioned, and you really don't necessarily need to use SQL to see this metadata. Keep in mind, this is only the second time that I've taught this using these graphical user interface clients. So while this will work and you can type these things no sweat into the old MySQL Workbench client, you don't really need to necessarily, perhaps with the exception of Describe. Describe can be a little bit useful, but when it comes to metadata, show databases will output the names of all these directories, but you can see all of them right here from top to bottom on the left-hand side. So you don't really need it. Show tables will give you a list of all the tables in a given database directory. Clicking on the down arrow here will do the exact same thing. Our tables in the employees table are department underscore employee, employee salary, and title. There's the tables. We want to see, okay, what kind of attributes are in a given table? Click on the down arrow for the associated table, click on the down arrow for columns, and we see that the two attribute names in our department table are department number, spelled DEPT_NO, and department name, spelled thusly. And so you can find this metadata in this modern client very readily, okay? So that is all we need to worry about with that. All right, so the main event, getting information, and I will give you a break shortly. I just want to get to a good stopping point with this, and then we will transition to the lab. Getting information out is the name of the game. It's the biggest deal going, and let's take a look. You can get information out of the database without even referring to any actual table or database or attribute. We can do things like select 2 + 2. And again, it's super tiny and I wish I could make this bigger, but if you're following along at home, it gives you the answer is 4. Or we could do more interesting things like there is a built-in function that will give us the current date and time. That function is called now. And now is followed with an open parens and a closed parens because now is a built-in function that takes no parameters. There's no information that you need to give now to do its job, but you still need to specify the parentheses to say, hey, I'm referring to a built-in function that MySQL has available to it, and so you have to have the parens. We'll also see in just a second a built-in function that needs a parameter. There's also others that need multiple parameters. So if we look at select now, you can see it's 1/22/2025, and we have a different time zone. We're not in the same time zone. Oh no, we are. Well, not quite, that's 6:12, we're 7:12, right? Or no, it's midnight. Yeah, so it's 00:18 and 12 seconds is that. So we don't have exactly the same time as the server that's sitting wherever was cheapest. But one thing to take note of with dates is the default date in MySQL, which for my money makes way more sense than our convention, is 4 digits for the year, dash, 2 digits for the month, dash, 2 minutes for the day. So it goes for biggest and most salient to next biggest to smaller still to smaller still with the hour to smaller still with the minute to smaller still with the second and microsecond. So it's going big, small, left, right, makes a lot of sense to me. Hopefully it does for you as well. Let's talk about a built-in function that actually takes a parameter that needs to know something for it to do its job. We could do square root and say select the square root of 16. You know, when you want the system to do a square root for you, you have to tell it what number you want the square root of. So that's the crux of parameters, is these things need you to tell it what you want acted on. So, and if we do the square root of 16, lo and behold, we do in fact get 4. All right, so there's just some quick exposure to built-in functions that allow us to do more powerful things. We haven't really gotten anything data yet, but I want to hit that hard right off the bat because so much of what makes a relational database powerful is all of these built-in features. It's very similar, it has a similar feel to it to Excel, right? I mean, a lot of this stuff, if you've done Excel stuff, feels Excel-ish. And if you have that analogy to draw on, it's very useful. But let's focus now on actually getting information out of the database. We've already done something along these lines. Let me be a little bit more systematic about it. Select asterisk is just a stand-in saying, give me all the attributes you have in the given table that I'm about to be referencing. It stops you from having to manually type each and every one in. This is a shortcut to that. So select asterisk from, and then you can click and drag a table name to stop typos from happening. That's quite handy. And control enter. And lo and behold, these are all of the records in the department table of the employees database. Okay, so there's the basics. Let's do some filtering. That's where things get interesting. The easy filtering is filtering columns. Columns contain attribute names. So rather than specifying all of those, we can specify some of those. We can specify one, or we can specify a comma separated list of others. If, you know, because some tables do get extremely wide and it's kind of overwhelming to see every attribute name if we're only looking for a couple. So we can filter by column. Easiest way is to click and drag. We've got department number here. We can just click it right in there. And if we do that, we will find that our output has been limited to the department number row. Whoop-de-doo, right? Not difficult. We can also, let's pick a different table for doing this. Here we go. Let's say we're going to query the employee table now. So we're going from an employee. And let's do multiple attributes. We can do select employee number. And these have to be comma separated. Space doesn't matter. Employee number, birth date, and what the heck, first name. Why not? From employee. So this space, no space doesn't make any difference. More readable if you provide spaces after your commas. Cannot have a comma after the last one. That will give you an error. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the blah, blah, blah. If you hover over this, it will give you the entirety of the error message. It's all the way down here and there's no way for you to see it. What matters is that you know to hover over it to see the entire message when you're working at the machine in front of you. That's really important. So then the big main event is filtering by row. This is powerful. This has a lot of different sophisticated options. This is where things start to get interesting, okay? So the syntax of a select statement, which is what enables us to do a query that is actually a query, a question that we want answered. We specify select, then one or more attribute names or asterisk for all the attribute names. Then we specify from, then one or more tables. We will, for this week and up until probably the midterm, deal only with querying a single table at a time. That is much easier than querying multiple tables. You can't get useful information from one table. So we will be doing something very artificial because you got to walk before you run. We will be querying one table at a time. But just think about our example with Spotify and artists and albums and songs. We'll be able to get anything we want about songs, but without any information about artists. Or we'll be able to get any information we want about albums, but not the songs that are in them or the artists that make them. That's weird, that's artificial, and that's not reflective of how actually doing this stuff will work. But we'll get there. When we come back from break, want to talk about querying, filtering rows or records or tuples. That's important to do. That gets interesting and complicated. Go ahead and take 10 minutes, attend to biology, get yourself a nice snack, refresh yourself as much as 10 minutes will afford you to do the opportunities to do. Uh, um, 10 minutes from now. Looks like, yeah, 7:47. 37, 40. Right. Watch.
already. Like, things like, I think, build the type of charter base. But that's like, I mean, like, chasing that thing. Well, forward, grab the bridge. Okay. Maybe just go too hard.
That's interesting, it's not.
That would.
Alright. For the assignment that's due tomorrow. Like, I'm just looking at it.
Yep.
But it's like list the tables contained in the university database. Are we like doing that, screenshotting and sending it, or like how are we left to listing it?
That's a great question. What you can do is. Because in the university database, it's all very small, you just click in the upper left corner, copy. And then in Word or Word, whatever text editor you want, then paste. Oh, and this is probably quite big, yeah, this is much bigger, so just copy and paste.
Gotcha.
And the reason I want you to get in the habit of doing that is because as the queries get much more sophisticated and complicated, stretch across multiple lines. Seeing what output you got will help me understand where you went wrong.
Gotcha.
Yeah. Good lord.
That was all.
Okay, if you're just waiting for others to come back, what I think we should do is go into the module for week 2, find the lab. Open up in a separate tab the tutorial, because that will step you through this. And you should have, we covered how to do the first 4 questions. So let's go ahead and get cooking on the first 4 questions. I will interrupt you at some point to discuss our next topic, which will be filtering by row, which is a good meaty thing, but let's get some progress under our respective belts and get some of this banged out. And I'm here as a resource. If you are stuck or confused, don't be shy. Let me make sure that the university database made it onto the server. Kind of unsporting if it didn't. Yes, it did. All right. Yay. University, tables, class major, prereq, professor, section, student section. Yep. All right. Yes, Anthony.
We both have that on our left side as well.
You should. I hope you do. If you don't, I'll be a little sad. Okay, so there you go.
Is it in there?
And there's.
Okay, so I did just like use the same one from last class.
No. I did not grant access to that, would be my strong suspicion. Because you have everything else exactly right. So nobody has access to the university.
Should be in here.
Yeah. Okay, well. So through no fault of your own. You you don't have access to the database that. Let me see if I can remember my database administrator SQL to fix that in real time. You may be off the hook for the lab. Let's see here. All right, so here's a completely different sort of SQL that we won't talk about at all. Grant select on university dot asterisk to asterisk dot asterisk. Crap. I can't remember. That's not gonna do it, I bet. All right, let me refresh my memory on how to grant access. Maybe we can do this real fast. Okay, very good. Public. And. What you said? There we go. Let's see if that. Yeah. Slow. Yep, I'm gonna have to figure out how to get everybody access to university.
It doesn't just like. Let's just push. Oh, yes, it can.
Well, it's just, it's telling me that I don't have permission to create a user with Grant. I'm logged in as root, so I can't imagine why that would be. But I'm a little stymied and I'm not super good at, oh, users and privileges, here we go. Here they are, that's all well and good, but. Add entry, yeah, okay, so this is great, except I'm gonna have to go through and do them one by one. Yeah, if I were to, I mean, I can go through and do them one at a time. I prefer not to. Is anyone 11 or 12? Student 11 or student 12? Tristan, would you tell me which student you are? 15, all right, very good, thank you. Let's go to do, add entry. Select schema, schema is university, okay. Select. Select all, no, I don't wanna do that, that would be dreadfully bad. Unselect all, there we go, select. Select all. Yep. See, I don't, when I get super panicky whenever I have to do it in front of everybody, apply. All right. Now, if you would, there may be some way to refresh, but if you could just close out of just the whole application, if you don't mind terribly, it'll remember, oh yeah, you're on your little machine anyway, and fire it back up. And log in, very nice. And sneak on over to the schema side and see, yeah, see you have it now, right?
I don't have it.
Yeah, I know, let me see if I can do it without having to go through everyone individually. And I don't want you to rush, and we're already running a little tricky on time. Yeah, it won't let me do. Yeah, all right, so here's what we're gonna do. We're gonna hold off on the lab until next week. My apologies for not having my I's dotted and my T's crossed. I don't know what happened between this time and next time, but it'll take me forever while you just sit there. To get everybody done. I mean, I know what I need to do, but I need to be able to do it in a single SQL command. It's not allowing me to do that. I don't know why not. That's neither here nor there. But what I can do instead, I know it's gonna be a little dull, but what it allows us to do is to give you like a follow along on your machine for filtering, so that we can get a really good foundation on some of the more complicated stuff. Because I don't like where we were headed, which was me just scratching the surface of the sort of things you need to do and then turning you loose on the lab. So let's stick a pin in that. My fault, don't worry about it. And if need be, I'm gonna see how we're doing in terms of progressing towards the material we need to cover for the midterm. And if worse comes to worse, I just give everybody a 10 on that lab. Anyway, let's just, what I would ask is that you log in and follow along. And let me know if I'm going too fast and actually do this stuff, and we'll just do it together. I know it's not as interesting, it's honestly, it's not as good a learning experience, but it's all it can offer up, because you'll be putting on your coats to go home by the time I've got everybody hooked up with access to the university database that all the labs are built on. Yeah, do you have a question, Ryan? You having trouble getting into the here, let me come over to you. Yeah, we definitely want to get everybody hooked up with access, that's for sure. Yeah, you double click it. Or single as it turns out, yeah, and now you can, so go into, instead of that, go into the other one over there, I think so, yeah. You have a Mac, don't you? Alright, okay, so I don't know where.
Yeah.
That is. My eyes are getting bad, I'm gonna have to actually get my nose in here. Schemas, there we go. You have university.
I have a slate one.
Yeah, you have university, which is good. Do you not have any other?
You know what I'm saying?
Let me just see what the heck is going on here.
Wait, could that be?
Show tables.
Wait, to carry.
Show tables. University is the only one that your account has.
Mine's an M2.
Which student are you? 11. Student 11. All schemas. All right, log out and log back in, Ryan. I think now you should have access to everything. There. Okay, so you're good for following along. Let me make a note. Not like it'll be hard to remember, but. All right, my sincere apologies for that. Let's make the most of the time we have. Let's talk filtering. So our pattern, select, set of attributes, either comma separated, single, or asterisk for everything. Then from and a single table until further notice. Let's make that table employees. Actually, I'm gonna do university, why not? Well, because you can't follow along, that's why not. Dang. All right, well, employee's not perfect, but it's fine. So select all from department, and I'm just clicking and dragging that table over. And if we do Control Enter, we can see a bunch of departments, their department number, which is a unique identifier, and a name from each department in this database, okay. Now, what we want to start doing here is filtering by row. Department turns out is not a good table for doing that. Let me make this bigger so you can see. Let's select all from employee. Then we will have some things to work with. So our syntax for filtering by row is as follows. We will specify a where condition. We want these attributes from this table, but only where a condition is met. So the condition will take the following form. Attribute name, operator, value. Okay, so we will say something like, say we're interested in doing something with only the employees who identify as male. We can say where gender is equal to And then M in quotation marks. So a note on quotation marks. When we are dealing with numeric data, we do not need them. When we are dealing with text data, we do need them. Why is that? Because we can also, when you type a string that begins with a letter, the SQL interpreter doesn't know whether you mean a literal value that you're trying to match. Like in this case, we're just trying to match the literal value of M. We only want the records where the thing that lives in the gender column is the text character M. But it could be, if we didn't have those quotation marks, that we meant a different attribute name. Because you can do comparisons across attribute names as well. That's more sophisticated. We won't worry about that for a while, but that's why when we are referring to attributes that contain character data, string data, text data, those are all synonymous for our purposes. You need to have quotation marks. Although, with each passing iteration, the system gets smarter and smarter, and sometimes it's possible, not in this case, luckily, but sometimes it's possible to get away with misrepresentations. In this case, if we skip the quotation marks, it's going to say, select all from employee where gender equals M, unknown column M in where clause. See, it thinks that there's a column called M that we're trying to compare the gender column to. Add the quotation marks in, and we're back in business. Double or single does not matter. Obviously, they need to be consistent. If you have one of each, you will get an error. And you say, okay, that really seems quite straightforward. And you're certainly right. Equality is not the only comparison operator we can use, though. You can do not equal to. And if we do not equal to, we'll get all this is everyone who isn't categorized as gender male. All right. We can also do greater than or less than when we're dealing with numbers. Greater than or less than with text data is possible, but not terribly useful. It's basically alphabetical. We could say gender greater than M, and we would get ends, which is not available or not applicable or something. It's not a very 21st century gender scheme. You'll forgive me for having this for decades. Yes,
And
Bella.
What if you want just male and female? So you just write.
Excellent question. So there we have some options. What we need to do there is bring in Boolean operators, and that's and, or, nor, not. And actually, I think I have a good slide with it. Chances are you've had some exposure to this previously, but no problem if you didn't. Let's take a look down here. Somewhere we got and is the intersection of two, and this is worth noting because it's different than informal usage. You know, if you have peanut butter and jelly, you need both on your sandwich. If you have just peanut butter, that's not peanut butter and jelly. If you have just jelly, that's not peanut butter and jelly. Or either one or both will get the job done. Not is peanut butter, not jelly, means if you have jelly, it doesn't meet that condition, right? The other thing to make use or make note of is that, remember, please excuse my dear Aunt Sally and the fact that there is an order of operation with arithmetic. There's an order of operation with Boolean operators as well. And is evaluated before or. And that will screw you up, almost guaranteed, on a test. It's the thing that's most frequently gotten wrong on tests and homeworks. Probably literally. And I see analysts do it, in real practice, and they get wildly, obviously incorrect results because they're not committed to using parentheses. So you don't need to memorize that and is evaluated before or necessarily, but you have to get in the habit of putting parentheses around the stuff that you want to be evaluated together. So let's look at an example of that. Anthony has a question now.
Is the greater than or equal to or the select from, is that based off like alphabetical order?
Yes, yes. And again, generally speaking, we would not use that in that way. We can though, where gender is less than M is going to give us female. And sure enough, it does. So that's an alphabetical thing, that's not useful, that's not something that I intended to cover. It's just as it just so happens. But Bella's question is leading us directly to where we're headed anyway, which is how about just male or female? So we can see where gender equals F, or, and here's the tricky part, you got to repeat both parts of the comparison, the attribute, the comparison operator, and the literal value you want. So, or gender equals M. And then the N category will be omitted here. All right. So one thing you may note is, wow, that syntax is kind of tedious if you got 15 different things that you want to filter. And that's absolutely true. We have a shortcut available to us as well. And nothing I've said so far, other than the alphabetization using greater than or less than, is not covered in the tutorial reference. So don't worry if you don't remember everything. So instead of saying or where, you know, where, and gender's not one because there's only 3 values in the database, but say it was department, we say where department equals HR, or department equals finance, or department equals accounting, or department equals accounts receivable. It gets tedious, so we have a built-in operator to save us that pain, and that is the in operator. It takes a set of comma-separated values with the quotes so that we could say M, F, and N. And that's just going to give us everything, but it's an example of how it's a more compact syntax that allows us to string together a bunch of ors. Okay. So in is handy. Let's deal with date. Oh, question.
That one, you don't put the equal sign, you just put the.
In is our operator. It's something that, you know, is not arithmetic, but it is a comparison operator. We could also say not in. You can add a not here. And what do you suspect this will get us? Given that the only categorizations in the database are M and F and N. It's going to get us nothing because those are all the possible values. So if what's in there gets us everything, what's not in there is going to get us nothing. And sure enough, it gets us nothing. So there are other operators available to us in SQL that are not strictly arithmetic. The most common ones are equals, not equals, greater than, and less than. But we have others at our disposal. In is really great because it saves you from having to do a lot of typing. There's also more than one way to do it. We can specify not equals by saying exclamation point equals. That's not equals. But we can also say greater than, less than. Then see where gender is greater than or less than F. That's going to give us the N's and the M's. Oh, okay. Let's talk dates. Dates behind the scenes are numeric, but when we refer to them in the way, using the human convention, they're going to be, we're going to treat them like strings, because they are strings. So say we want where hire date is equal to, and I don't know why that highlight is there. Why is that highlight there? Oh, well. And I'm just gonna pick a one that I see literally is here, 2012 04 27. We have to use this somewhat unfamiliar but very sensible convention of year, month, then day. And if we do that, we should get at least one result, probably more. Let's find out. Just the one. Gregory Dredge. Okay. So when we interact with dates, we'll treat them like strings. Behind the scenes, they're recorded as the number of microseconds that have transpired since the Unix epoch, which was, I think, January 1st, 1970 or something like that. We will spend a lot of time in this class tearing our hair out over dates. Date arithmetic is, I think I have a particularly bad brain for it, but I don't think anybody finds it completely effortless. One thing that's likely to trip you up when we get to date-related comparisons is what's bigger and what's smaller. I very reluctantly take small amounts of points off for this on tests and homeworks all the time, because there's an impulse to get it backwards. And this is why I like the fact that MySQL puts the year first. So if we're saying where hire date is greater than 2012 4/27, is that people who have been hired more recently or less recently? More recently, yes, more recently. I heard less whispered. And like I said, if you whispered less, I'm with you. I really have to be super ultra careful about this. My brain is dying to get this wrong, and so are a lot of other people's. So think about the year. If hire date is bigger than 2012, it's going to have a bigger year. If it has a bigger year, it's more recent, right? It's closer to 2025. So that's kind of how I resort. And oh my goodness, and Widener students are pretty good about their basic math, in a way that not everybody is. And maybe your mileage may vary. I hope it doesn't, but I've always been pretty impressed. The one thing that screws people up, even worse than dates, is not knowing which one's greater than and which one's lesser than. And so I'm going to assume you all got it down, but I'm still going to say it. The alligator wants to eat the bigger number, people, right? The side that opens that's the bigger. So just keep in mind, the alligator's hungry. He wants the bigger thing. You don't even have to remember which one's greater than, which one's less than. Just make sure the alligator's eating the bigger one. Otherwise, you're likely to screw things up, even in ways unrelated to dates. So if we say where hire date is greater than 2012, we're going to see results that are more recent than 2012. And let's take a look at that. And we can order them here. And sure enough, the smallest one is 2012. The biggest one is 2019. And things are making sense there. Okay. Let's do an and an or together. Let's say we're interested in the non-male employees. So we'll say where gender is not equal to male. So we want the non-male employees, and we want the other employee, and we want every employee who's been hired more than, let's say, we're going to hard code it, but let's say earlier than 2015. And so we can use ands and ors in this way. We could take hire date and say it's smaller than, because we're going further back, we want people who've been hired before that, so it's going to be less than. You can break things across multiple rows freely. It won't execute until you click the little lightning bolt thing. So let's say hire date greater or less than 2015-01-01. Now that doesn't give, see, the other thing is I wasn't planning on doing this, so I'm kind of vamping these examples. But what we should see is no one's hire date should be earlier yet. So the latest hire date is 2014-12-25, close to our cutoff, not pat, but it's on the right side of it. And we have only non-males. Yes, Sean.
Does the exclamation point mean again?
The exclamation point is one of the ways we can say not equal to. It's a shortcut. We can also use the literal not. And the other option that people enjoy that does the exact same thing is greater than, less than. But it is a negation.
Why do we have to put the date in quotations? It's not.
Because, so obviously dates behind the scenes are treated as numbers, but we're not treating them that way. We are using our human readable convention. And it's a string that is made of numbers, except for the dashes. The dashes aren't numbers, so it's not really a quantity so much as it is a pointer to a place on the calendar that can then be taken by the machine behind the scenes and converted into a number by saying, okay, how many microseconds is this plus or minus from the reference that I use, which I think is 1/1/1970 for whatever reason. So I don't know if that's a satisfactory reason, but that's why. So then so what's probably pretty self-evident but worth noting nevertheless is we don't store ages in the database. Why not? Right, they're constantly changing, right? You know, your birthday today is not necessarily going, your age in days is not going to be the same today as it's tomorrow. We store the unchanging thing, which is the date in question, but oftentimes we have to deal in ages, right? So we have some built-in functions to deal with ages. And imagine, you know, accounts receivable, we want to know which invoices are more than 30 days overdue so that we can hassle some people or whatever you do. We're constantly asking questions of our data related to dates. And more specifically, ages. So let's talk, because this is one of the harder things, about calculating ages. Now I want to bring to your attention the fact that there's somewhere in here, I'm going to make it a little smaller so I can see it. There's a whole section on dates. And there's a whole dealing with dates section. And there's a lot of different date functions to make our lives easier. So there's more than one way to do it. In the same way that exclamation point equals is the same as greater than, less than. We got more than one way to do it with dates as well. Let's start with the date sub function. No, that's not gonna work for us. I think we should do date diff first. So the other thing that is worth knowing is when we want to calculate the age of something, we need to know where to start. Where we want to start is right now, right? I would love to tell people my age 15 years ago, but I'm typically duty bound to tell them my age presently, not 15 years ago. Nobody cares how old you were 15 years ago. Plus they can figure it out from there by adding 15. So our reference point is the current date. What I never, ever want to see anyone do, because of how deeply useless it is to hard code the present date into your query. That is not above board in the class. You can't manually type the current date in, because then instead of, like Madison said, your age being wrong because another day has passed, the query is going to be useless because another day has passed. So our referent has to be the present date, and luckily as I believe we may have mentioned, we have built-in functions for that, like now. So by selecting now, what we will get is the current date and time. Using now together with date attributes, we can start doing age-related math. So let's say we want to see how long some employees in the employee table have worked for us. So we'll say select everything from, try to get in the habit of typing this caps. Doesn't matter, it just looks nicer. Any of the SQL language words can be uppercase, lowercase, doesn't make any difference. From employee, I'm dragging it over there. But let's say instead of, we want to see their age of their service or how long they've been here as something that comes out when we press enter. So we're going to put it as an expression in the select clause. And this points to one of the things that you're going to have to start thinking about. There's no easy way to teach. It's not conceptual. It's just something you have to wrestle with, is where am I trying to put the components of my query? Do I want to filter by this? Or do I want, is this something that I want to see spit out when I press return? So sometimes we want to filter. We only want to see the invoices that are over 30 days old. That would be something that we put in our where clause. Sometimes we want to say, I want to see the age of service of everyone in the such and such department. That is something you want to see spit out on the screen. So that's the select clause rather than the where clause. We will spend the entirety of our however many weeks together worrying about what goes where in that fashion. If we want the age of service to spit out, we need to put that in the select clause. So we can say, we have a function called dateDiff. One of our built-in time-related functions. Okay? And it takes two parameters. The bigger date and the smaller date. And what it does is tell you the number of days between those two dates. So let's do one really boring and uninteresting here. This starts to get a little tricky, but let's just say dateDiff 2025-01-21, that's today, right? And 2025-01-20, that's yesterday. What do you expect? Question?
For the month, you have to put 01 or page 1.
Yeah, I think it needs to be 2 digits. We'll test that. That's a good question. I'm almost positive it needs to be both, but we'll put it to the test in just a second. What do you suspect the output will be here? Exactly right. 1. Because that's how many days are between these two things. There's nothing complicated about this, but when you start adding stuff together, it gets a little confusing. Now, Anthony, excellent question. I wish I could answer it confidently, but I'm pretty sure this is going to be an error. Oh, nope. Nope, that works just fine. What an age we live in. There was a time when it didn't, but that works fine. I don't think we'll get away with that. Oh, yeah, sure. We can get away with that as well. You didn't used to be able to. Still good practice to go, I mean, especially with a year, go all 4. It will make all sorts of intelligent guessing, except that sometimes intelligent guessing is dumb guessing. So don't test its limits, but turns out you can cut those corners. So if we were to replace this first date with an expression that just looks up today's date and time, like so, we would expect the same result, right? Because now is going to give us, well, now, which happens to be the 21st. It doesn't. It gives us 2, because there is an assumption about the time if you do not specify it. I'm wondering if we do current date. Oops,
Is your time technically tomorrow? Cause your time is all.
It's like 12 o'clock.
yeah, no, that's why,
I got two.
I can't remember what current. What I gotta look it up. Yeah, I'm wondering, there's also a shortcut for just date without time, current underscore date, yeah, okay. I'm wondering if that will give us 2 or 1, yeah, that gives us 2 as well. In any case. Devil's in the details with things like this, and if you need to specify times, you should specify times. But we also should be working for the same time, correct time zone, and we aren't. Holding that complexity aside, by specifying current date or now instead of hard coding the date, this will be as accurate, 17 days from now as it is currently. So this is the only thing that's acceptable, is that which will remain accurate at any time you issue it. Okay, that's important. So instead of the same way that we can put current date in to get that flexible, let's, instead of hard coding a second date, let's try the higher date. We drag that right in here. And now we're gonna have to put back our from employee. And here they are. They're the duration between now and their hire dates for every employee. Only it's in days, not years. So it's kind of hard to wrap your brain around. So here's where we start stacking things together. We've got this date diff function built into MySQL, takes the big date first, smaller date second, and gives us the number of days in between them. But typically when we're looking for the age of things that are thousands of days old, we want that expressed as years. How do we take days and convert them to years? Well, it's a somewhat imprecise undertaking in this case, but we can divide that by 365. Now we're starting to build something kind of interesting. And now if we execute that, we see that we have something that looks like years of service here. One thing that's difficult here is we don't actually have the name of the individual. So we just have a bunch of naked years of service without any referent. So we probably want to put the first name and the last name and then the date of service, right? Now we're starting to build something kind of interesting. Let me see if I can. Hopefully that is still readable. Although you can just break it. Okay. The other thing to note is generally there's some other interface that's being provided to the results of these SQL queries that we're running. Someone ultimately will see them in a report, they'll see them in a dashboard that they're accessing over the web. They are not going to be looking at this in the way that we are as the people who are writing the queries. However, sometimes you're just copying it into a Excel file or a database, or an email even, or something like that. We may want this heading to be a little bit more descriptive than it is currently, in which case we can give it a shortcut alias. And it will be useful for us to know how to do that, because sometimes to achieve our ends using SQL, we will need to assign aliases. So all we want to do if we want to give it a better name is put the name in. It has to either, you really should get in the habit of making sure it's all contiguous, no spaces. So let's say years_of_service. just like that. And then when we execute it, you just get years of service instead of that descriptive thing. Now, if you want to put spaces in, you can, but you need to put it in backticks, the thing that's all the way in the upper left of your keyboard, like so. That works fine too. I hate backticks. Backticks can translate poorly, but they are an option to you. So you can give more descriptive names if you want. Go shorter, years of service. We don't need the backticks for YOS. But one thing that's troubling me here is we have this, we have too many decimal places here. And when we talk about years of service, we typically talk about even number years of service. Same with age and so forth. So let's stack even something further and round this, right? So we can take this result right here. Here's where, you know, your parentheses start coming in handy, right? And we can apply the round function to that. So we've just put this whole jobby, which is currently outputting these things, and we are applying the round function to it. And by so doing, we get an even integer years of service. Now, do I need to slow down? Any questions? Concerns? Yes, Josh.
Are you able to round like decimal spots?
Yes, you just anticipated my question. Round is one of these functions that can take a single parameter here, and it just goes whole integer, or you can give it an optional second parameter and get as many points to the right of the decimal place as you want. So let's do exactly that and say, all right, this jobby here is our first parameter. That's what we want rounded. Let's give it 2 decimal places, right? And there we go, 2 decimal places. Pretty nifty. But when it comes to years of service, certainly when it comes to age, you know, let me tell you, it's my wife's birthday today, and we're the same age normally. But from today until March 28th, she's a year older than I am. She's not a couple months or a day, you know, it's a year. We deal in years. And I am 53, whether I am 53 and 364, 365ths, I don't round up, I truncate. I drop that fraction. That's how we deal with age, whether we're starting to be concerned about it or not. You're not 15 until you're damn 15. Doesn't matter that you're 14 3/4, you're still not 15, especially true for 21. So let's not round, but rather truncate, so that we just drop off that fraction. So now, instead of seeing Georgie Ficello as being 19, we should see them as being 18. I want to get rid of those 2 though. We just want a full-on truncation back to years. Let me see what went awry there. How do I have it? Open, open, close, close. I don't know where my error is here. Is truncate not the deal? Well, this is most unfortunate. All right, so here's where we do what you typically do, MySQL truncate. It was truncate in Oracle. Versus round. Yeah, so it looks like that should work just fine. I don't understand. Okay, I guess it needs the decimal point. While round has two parameters, the second one being optional, it looks like truncate requires both parameters. Live and learn. Alright, so but now you see that Georgie Ficello, instead of rounding up to 19 because it was 18.59, we're being truncated to just 18. Whatever is not made it to the next integer is just dropped off. These are useful distinctions. There are lots and lots of built-in date-related functions. We can add a particular amount of time to a given date. We can find the day of week. There's no end of stuff. This is one of the things that you are 100% on the hook for, though, is being able to both display output through the select clause and also to use comparisons with ages. So give me all of the orders that were placed in the last 3 weeks. Fair game. Show me how old the orders are placed by customers who live in Ohio. Fair game. Those things are completely important. And one more thing I want to show you real quick that is somewhat tricky and worth talking about is, and especially useful with things like this, select all from employee where F name like, another comparison operator like is for inexact matching, pattern related matching. So we're not typing a literal string that has to be matched character for character, but rather setting some matching parameters. So this is good for getting things where you know it begins or you know it contains. So we can do something like, we know that the first name started with F, although we need that in quotes. So we can say F and %, and this will give us every first name that begins with F. No, it won't, because I have space. Oh, it's not F name, it's first underscore name. There we go. Now we're back in business. So the % says any amount of any character. So what this is saying, it's going to start with F and then any amount of anything we don't care. And we can say this is not a super common thing to want to do, but we can also say %F, or let's say A, %A. So this will give us everyone whose first name ends in A. Sania and Margareta and Mona and Kendra and so forth. And we can also do single character. This one is handy for Ryan versus Brian, which I think we referenced earlier this evening. We could do the underscore to specify a single unknown character. So if we say underscore RYAN, that will give us Brian and Tryon and any character plus exactly that string. That's actually useful for my name. You know it's Brian, but you don't know how it's spelled. You could say BR_AN, and that will give you, well, in this case, it won't give you anything, but if there were a Brian or Brian with an I or Brian with a Y, that would work just fine. And with that, am I cheating you with some valuable time by letting off at 8:30? Is this a standard thing to do? Okay, not getting a lot of yes, but yeah, okay, let's call it a day. My apologies for not having the lab together. I will get my act together in short order. In light of the lab being inaccessible, there is yet again nothing for you to do, but I would encourage you for this week, and if you can swing it next week's as well. Well, I told you don't bother with the videos for the first week. They're they're out of date and not terribly technical. The material for this week and next is worth reviewing. It will keep you well positioned to absorb what we're going to talk about next week. Thanks for being here and your attention, and see you in a week. You can just leave your name tags, I'll collect those.